Hello everyone. Welcome to Chemistry 1135, specifically Chapter 1 for Chem 1, which is all about a review of classifying matter as well as dimensional analysis. And the specific title of this chapter is called Matter on the Atomic Scale. But I really think that a better title would have been a review of how to classify matter and how to do dimensional analysis, skills that you should have already learned or at least are familiar with from a high school chemistry or an intro chem class. So we're going to take, if they're a little rusty, that's fine. We're going to go ahead and take some time to review those skills and do some practice problems in this and in subsequent videos. So if we needed to define what exactly are we going to do for the next 16 weeks that we're together? Well, we're going to be doing chemistry. Specifically, we are going to study stuff, specifically matter. That's anything that has mass and occupies space. We're going to study stuff, and we're going to study the changes in physical and chemical states of stuff, and the physical and chemical states and the changes that happen when chemical reactions occur. So that's sort of a broad statement as to what we're going to be doing in this course. So this next slide, which there's a similar slide like it on your MindTap slides, but this is actually from the Intro Chem textbook that's used here at Rose, but I like it because it's a good summary of how to classify matter, stuff that we're going to talk about in chemistry. And so when classifying matter, one of the first questions that we ask is, does the sample that I'm looking at, does the matter that I'm looking at, does it have a variable composition? If it does have a variable composition, like a solution of salt water, that is a mixture because there are two different types of molecules present, water and salt. So matter that has variable composition is a mixture. If there's only one type of substance present in your matter, in your sample, then we say that is a pure substance. So for example, water, H2O, what you get out of the tap or here at Rose State, that is a pure substance. It's just water molecules. Salt, NaCl, that's also a pure substance, but when you mix them together, you get obviously mixture. Specifically, you get a homogeneous mixture. Homogeneous mixtures are those mixtures that have one phase. So you cannot easily distinguish between components. Heterogeneous mixtures you can easily distinguish between components. For example, if I had a mixture of wet sand, the sand and the water molecules are in the water, you could easily separate. Salad dressing is a good example of a heterogeneous mixture. We're going to talk about mixtures more later on in the course. What we're going to focus on in the next slide and in the subsequent chapters is on pure substances, specifically, in this case, elements. So if I have a substance that you cannot break into individual simpler substances, then that substance is an element. So for example, water would be a compound because you can't separate that into hydrogen and oxygen, but if you cannot, then that is an element. So helium, what's in the balloon here, that is a pure substance. And so take home message from this slide, I should be able to give you a substance, some kind of matter, and you should be able to classify it based upon saying that it's a pure substance or a mixture. If it's a mixture, you should be able to tell me if it is homogeneous or heterogeneous. And if it is a pure substance, you should be able to tell me if it's a compound, like water or sulfuric acid, or if it is an element, those beautiful things that are on the periodic table. And that's where we're going to start our next conversation, is on elements. So we're going to take that flow chart that was just on the previous slide and start to break it apart a little bit and talk more about those types and states of matter. So elements, as hopefully you remember from your high school chemistry or your intro class, that's matter that is the simplest type. You cannot further subdivide that substance without that substance losing its unique individual properties. And the smallest indivisible unit of an element is called an atom. Now we're going to talk later on in chapter 2 about the particles that make up an atom. But you cannot, those subatomic particles, you cannot muck around with and still have that same element. Okay? So elements, these beautiful things that are on the periodic table, all of those elements are made of atoms, and each atom for a particular element is identical to an atom in that same element. So for example, all the atoms of lithium are identical to each other but different from the atoms of beryllium or of magnesium. Okay. So elements, simplest type of matter, smallest unit of an element is an atom. What I have here is the periodic table that is from the MindTap online homework. Obviously, it's a bit outdated because we have some more elements down in this corner. We're going to talk a lot more about the periodic table in chapter 2. Suffice to say, you will be given a periodic table when taking quizzes and exams that'll look similar to this. So you do not need to memorize the periodic table per se, but you will need to memorize how to use the periodic table, and we'll talk about that in subsequent lectures. And you're also going to have to be familiar with names of certain elements. So those are elements. And while most elements do exist as individual atoms, like helium or sodium or potassium, there are some elements, for reasons why we'll talk more in detail about later in the course, but maybe you remember from intro chem, there are some elements that like to exist as diatomic molecules as their most stable state. Di means two. So there are some elements that in their most stable state, they like to be diatomic molecules. And the way that I like to remember which elements like to be diatomic molecules is that mnemonic, have no fear of ice cold beer. And that mnemonic is a good way to remember that hydrogen, nitrogen, fluorine, oxygen, iodide, chlorine, and bromine all like to exist as diatomic molecules as their most stable state. So in this lecture, and actually throughout this course, I'm going to be using the terms molecule and compound. I'm going to be using those terms a lot. And so I wanted to mention a important distinction between those two words. Now in lecture, I'm not going to be so picky about using them as distinctly different species. I'm probably going to I will use molecule and compound synonymously, but you should be aware of the fact, because this is also mentioned in your MindTap homework, that a molecule can refer to anything that is a collection of atoms held together by chemical bonds. Okay. So in this little cartoon here, all of these species would be molecules except for the single spheres here. Those would be single elements. Okay. The blues and the blue and the green with the purple, those are molecules. Compounds are substances that are formed when you have two or more different elements. So based upon that definition, let me get my little pointer here, the only compound that is in this mixture that I have, the only compound that I would have would be this green and purple. Those would be considered compounds. Okay. And as I said, I tend to use those terms synonymously or as synonyms. So don't be too concerned about it, but just that is mentioned in MindTap about the difference between a molecule versus a compound. Okay. So now we're going to mush on a little bit to talk about pure substances. Pure substances can be elements or compounds. For example, all of these species, these are elements. They are all pure because they have a well-defined physical and chemical property, and their composition does not vary from sample to sample. So pure substances can be elements. They can also be compounds. For example, water or HCl. That would be an example of a compound. When mixing those pure substances together, you get mixtures, obviously. And mixtures come in two flavors, as we said before, homogeneous and heterogeneous. Homogeneous, you cannot easily distinguish between components. Heterogeneous, you can. And so I think this slide does a better job of that.